Quantum computers, how superposition creates unbelievable power. Imagine a coin. It's not heads, it's not tails, but it's spinning, somehow being both heads and tails at the very same instant. Sounds like a magic trick, right? But what if I told you this is a real fundamental aspect of our universe? And what if using this idea could help us build computers so incredibly powerful they could crack problems we don't even dare to dream of solving today? This isn't some far-off sci-fi fantasy. This is the wonderfully weird world of quantum computers. Today we're exploring the core phenomenon that makes it all tick: superposition. Get ready, because the quantum realm doesn't play by the rules we're used to. The problem or current limitation, setting the stage. For years, the classical computers we know and love have driven so much progress. From the phone in your hand to the giant supercomputers forecasting tomorrow's weather, they all work on a pretty simple idea: bits. A bit is just a tiny switch that's either a 0 or a 1, on or off. It's a straightforward system that's gotten us amazingly far. We've literally built our digital world on this binary bedrock. But here's the thing. Some problems are just too monstrously complex for even the beefiest classical supercomputers. Think about trying to perfectly map out how every single molecule in a new medicine interacts. The sheer number of possibilities blows up so fast that a computer the size of a planet, running for the entire age of the universe, still wouldn't get through it. Or what about designing brand new materials with incredible properties, figuring out the tangled mess of global finance, or creating artificial intelligence that's truly intelligent? Classical computers, powerful as they are, just hit a brick wall with these kinds of exponentially huge problems. They have to chew through possibilities one by one, and sometimes that list of possibilities is practically endless. We need a new way to compute, a new way to even think about information. And that's where the quantum world, in all its strangeness, offers an incredible way forward. Introducing the solution concept: classical bits versus qubits. So how do we actually get past this classical wall? Well, we need a new kind of bit, one that plays by the quirky rules of quantum mechanics. Meet the qubit, the quantum bit. A classical bit, like we said, is definite. It's either a 0 or it's a 1. It's like a light switch, on or off, no middle ground. That's the foundation of all the digital stuff you use every single day. A qubit, though? That's a whole different ball game. Instead of just being a 0 or a 1, a qubit can be a 0, a 1, or a blend of both at the same time. That spinning coin analogy? It's back. While that coin is in the air before it lands, it's not definitely heads and it's not definitely tails. It has the potential to be either. A qubit, all thanks to this thing called superposition, is in a similar state, holding many possibilities at once. Picture a qubit not as a simple on-off switch, but maybe more like a dimmer switch that can be at lots of different brightness levels all at once. Or, maybe even better, think of it like a sphere. The North Pole is 1, the South Pole is 0, and the qubit state can be any point on the surface of that sphere, representing a mix of 0 and 1, with certain probabilities for each. This knack for being in multiple states at once isn't just a cool party trick. It's the fundamental thing that gives quantum computers their almost unbelievable power. It's like upgrading from an alphabet with just 2 letters to one with a whole spectrum of characters. Unveiling superposition. The secret. All right, now we get to the real heart of the quantum revolution: superposition. This is the secret sauce that quantum computers are tapping into. Superposition is a basic rule in quantum mechanics. It says that just like waves can add up and combine, quantum systems can be in a mix of multiple different states, all at the same time. And it's not that the particle is just flipping back and forth super fast. It genuinely is, in a very real way, in all those states simultaneously. Let's try to wrap our heads around that, because it really doesn't match our everyday experience at all. In our world, A cat is either alive or it's dead. A car is either parked in your driveway or it's down the street. But when you zoom way down to the quantum scale, the rules get seriously weird. An electron, for instance, doesn't always have a precise location until we actually measure it. Before that measurement, it can be in a superposition of many possible places, kind of like a fuzzy cloud of probabilities. The famous double-slit experiment shows this off perfectly. A single particle, say an electron, seems to go through both slits in a barrier at once. This creates an interference pattern on the other side, something that can only happen if it's acting like a wave and exploring multiple paths simultaneously. So when we say a qubit is in a superposition of 0 and 1, it means it has a certain chance of being a 0 and a certain chance of being a 1 when we finally measure it. Before we look, it's not one or the other. It's this delicate, probabilistic mix. And this doesn't just mean we don't know its true state. The qubit actually doesn't have a single definite state until that act of measurement forces it to pick one. This is often called the collapse of the wave function. It's just like our spinning coin finally hitting the table. Only then does it settle on heads or tails. The really wild part is that this isn't just some abstract idea. Scientists are in labs right now, creating and controlling these superposition states. It's incredibly fragile and easily messed up by its surroundings. That's a big challenge called decoherence. But superposition is a real, usable feature of the quantum world. And it's this ability of qubits to hold multiple values at the same time that's the key to the next giant leap in computing power. Section 4. How superposition leads to processing power. Okay, so qubits can be 0 and 1 at the same time. Why is that such a massive deal for computing? The answer is something called quantum parallelism. If you've got one classical bit, it can be a 0 or a 1. Two classical bits? They can be in one of four possible combinations: 0, 0, 0, 1, 1, 0, or 1, 1. But a classical computer has to look at each of these combinations one by one if it's trying to find a solution. Now think about qubits. One qubit can represent both 0 and 1. If you have two qubits, because of superposition and another cool quantum trick called entanglement, which is a whole other story, they can represent all four of those combinations: 0, 0, 0, 1, 1, 0, and 1, 1, 11, all at the same time. Add a third qubit, and it can handle 8 states at once. 4 qubits, 16 states. And if you have n qubits, a quantum computer can simultaneously hold and work with 2 to the power of n states. That's where the mind-boggling exponential power kicks in. Just 300 qubits, each in superposition, could represent more states than there are atoms in the entire observable universe. Now, this doesn't mean it just spits out the answer to any problem instantly. But it does let a quantum computer explore a huge number of possibilities in parallel, in a way that's totally different from how classical computers operate. For certain kinds of problems, this quantum parallelism can mean an exponential speedup, solving problems in minutes that would take the fastest supercomputers we have today billions of years. That's the incredible processing punch that superposition brings to the table. The benefit: real-world applications. This isn't just about crunching theoretical numbers either. The power of quantum computers, boosted by superposition, looks set to shake up fields that are currently stuck because of today's computing limits. One of the most exciting areas is drug discovery and materials science. Figuring out exactly how molecules interact is super complex. With quantum computers, we could model these interactions with incredible precision. That could lead to designing new life-saving medicines, better catalysts for industries, or even new materials with properties we can only dream about right now, like room-temperature superconductors. For example, Pfizer has teamed up with IBM to try and speed up the hunt for new antibiotics and antivirals using quantum computing. Google's quantum team is working on modeling protein structures linked to cancer. Then there's optimization. So many critical real-world headaches, from logistics and supply chains to financial modeling and managing traffic flow, are basically giant optimization puzzles. Quantum computers could potentially find the absolute best routes for delivery trucks, fine-tune investment portfolios to lower risk and boost returns, or even help design more efficient energy grids. Artificial intelligence is another area that could see a huge jump. Training complex AI models means digging through enormous data sets. Quantum machine learning algorithms might be able to seriously speed this up, leading to more powerful and smarter AI. And in a cool twist, AI is also being used to help make quantum computers better, for instance, by helping with quantum error correction. And you can't forget, cryptography. Some of the encryption that keeps our sensitive data safe today relies on the fact that it's incredibly hard for classical computers to factor really large numbers. Well, there's an algorithm called Shor's algorithm, made for quantum computers, that can factor these numbers exponentially faster. While that sounds like a future threat to today's encryption, it's also pushing scientists to develop new quantum-resistant ways to protect our data, making sure we stay secure in a quantum future. Plus, quantum communication itself promises new kinds of ultra-secure communication channels. Things are moving so fast that the United Nations has even named 2025 the International Year of Quantum Science and Technology, which shows just how quickly innovation is happening and how real-world uses are starting to pop up. Advances in fixing quantum errors and making the hardware more modular are bringing these applications closer than ever. Addressing the strange quantum phenomenon. Let's be real for a second. All of this sounds pretty bizarre, doesn't it? Particles being in multiple places at once? Existing in some kind of blended state until we take a peek? It's a lot to get your head around, and it definitely goes against our everyday gut feeling about how the world should work. This weirdness is something that even the folks who first came up with quantum mechanics struggled with. Erwin Schrödinger, one of those pioneers, thought up the famous Schrödinger's cat thought experiment. He did it to show how strange it seemed to apply superposition to big things like cats. He imagined a cat in a sealed box with a radioactive atom. If the atom decays, that's a quantum event, it triggers a device that, well, isn't good news for the cat. According to a straightforward reading of superposition, until you open the box and see what happened, the atom is both decayed and not decayed. And that would mean the cat is, in a way, both alive and dead at the same time. Now, this thought experiment was really meant to get people talking and thinking hard about how to interpret quantum mechanics. Specifically, it poked at the measurement problem. How and when exactly does a quantum system in superposition snap into a single definite state when it's measured? It's still one of the most debated and, frankly, still kind of mysterious parts of quantum theory. But here's the really important bit. Even though it's strange, superposition isn't just some philosophical mind-bender. It's a rigorously tested, experimentally proven phenomenon. Scientists don't just sit around theorizing about it. They actively use it. From atomic clocks that use superposition to achieve incredible accuracy, to early-stage quantum sensors, and of course the qubits in the quantum computers being built today, superposition is a tool. The philosophical questions it brings up about reality are deep, for sure, but it's becoming super clear how useful it is in practice. The quantum world is definitely weird, but it's also real, and we're learning how to tap into its power. So, let's quickly sum that up. Classical computers use bits. They're either a 0 or a 1. Quantum computers use qubits. And thanks to this amazing thing called superposition, qubits can be a 0, a 1, or a mix of both, all at the same time. This ability lets quantum computers perform a massive number of calculations simultaneously, giving them the potential to solve incredibly complex problems that are just too hard for today's computers. We're starting to see how this could translate into exciting real-world benefits, transforming drug discovery and materials science, optimizing huge systems in logistics and finance, giving AI a major boost, and completely changing the game for cryptography. Now, the journey of quantum computing is still in its early days. Building stable, large-scale quantum computers that can correct their own errors is a massive engineering feat. Decoherence, where qubits lose their special quantum state because of tiny disturbances from their environment, is a constant challenge. But progress is picking up speed, with new breakthroughs in qubit stability, error correction, and the number of qubits packed onto processors happening all the time. Companies like Google, IBM, Microsoft, and a whole bunch of startups are really pushing the boundaries. We're shifting from just talking about theories to actually seeing the first real-world applications start to show up. The future that quantum computers and the power of superposition could build is one filled with incredible possibilities. It's a future where we could conquer diseases faster, invent new sustainable technologies, and maybe even redefine what computation itself means. The quantum realm's superposition secret is out, and we're just starting to grasp the incredible power it gives us. What part of quantum superposition just completely blows your mind? Are there any potential uses of quantum computers that you're super excited about, or maybe even a little worried about? I'd love to hear your thoughts. Drop them in the comments below. If you enjoyed this trip into the quantum world and want to keep exploring the cutting edge of science and technology, make sure to hit that like button, subscribe for more videos, and ring that notification bell so you don't miss our next exploration. Thanks for watching, and stay curious.